All right, good evening. Thank you everyone for joining us tonight. Thank you everyone that's on YouTube following us. We think last meeting we had here in BNY, I think we're gonna try to have our meetings at BNY Mellon. Hopefully we can have the same place for the rest of the year. I think it was like that when we were at Credit Suisse, so it's very easy. Everybody knew, okay, it's gonna be at Credit Suisse. So moving on, I think people get used that it's gonna be at BNY Mellon. So again, thank you everyone for joining. We'd like to thank BNY Mellon again for hosting us. I would like to thank Andrews. Andrews, if you want to come forward. Andrews works at Object Style. And for those here, I think some of you are gonna have known Apache Cayenne. How many of you use it, Apache Cayenne? I use it. How many of you have heard about Apache Cayenne? Yeah. So this is the person who created it, right? It's right here. So thank you very much. And he's sponsoring the pizza. It's very nice to have you here, Andrews. Thank you very much.
Yeah, all right. Okay, hi guys. Good to be here. Thanks for the introduction. And yeah, I'm Andrews. I run a company called Object Style, and we're a software services company. So we program in all different languages, different technologies. We build teams for our clients. But I'm a Java developer, and this is how the company started around Apache Cayenne at that time. And in addition to Cayenne, so I'm still very passionate about open source, very passionate about Java. I participate in maybe 5 open source projects right now. So my GitHub is like profile is evergreen. So let me mention just a few of them, and for the presentation. So Cayenne it's an ORM, of course. It's an alternative to Hibernate. We're solving the same problem, essentially, just a little different. And another thing that I'm working on is it's called Boutique with O, Boutique.io, and it is a strong alternative to Spring Boot, and we started it probably at the same time as they did, and like because we weren't happy with what those guys had. It has a focus on like being like more lightweight and performant, so no slow startup times and all that. Another project is it's called agrest.io, and I don't know if, how many of you know about GraphQL. Yep. Okay, almost everyone. So GraphQL, of course, it's that technology that allows to prevent multiple calls from the client, so simplifies the client and moves all the data aggregation and processing logic to the server, and allows the client to request like a part of the graph that it needs to render something. So the same endpoint, for instance, can render like a mobile app, and can render a website or there's much more information. So we had a different idea at approximately the same time. It was like maybe 6 months before GraphQL got released. So we created the same thing, but based on the REST. So you can actually use get, post, put, and everything. So like you use the same familiar vocabulary to build your web services. And so that's another project. And currently I'm actively working on DFlib. That's a data frame, data structure for Java. So that's essentially a data structure that is missing in Java, among all the lists, maps, and sets and everything. So there's, I want to have a data frame and not have to do it in like Scala in Spark, for instance. So these are projects. If you're interested, feel free to check out. And thanks for being here, and looking forward to the presentation.
All right. Thank you very much, Andrews. And thanks again for Andrews and Object Style for the pizza. For those online, please, if you're not following us on Twitter, please do it at NYJavaSIG. Let your friends know about us. Here in the room, who is the first time in the event? Anyone first time? Thank you very much for joining us. How did you know about us? All right. And you found the best one. You're lucky to be here. You're the first. time in person. Used to attend only virtual, but since you are dealing with good, thank you for joining. If you're following us online, I hope you can come in person next time. Don't miss the opportunity to network. So enough of talk. So tonight we're gonna have my dear friend NYJavaSIG. So for everyone that ever studied for certification since Java 8, right? Since Java 8, Jean has been writing books, about certification books. They are the most popular books on certification. True story, every time I find a trick question, I message Jean and said, what's the right answer? I never win. I never win. I never win. And there was one time that I sent to her and she said, option is C, but not because what you're saying, what you think. You pasted the code wrong. So I knew that from now, as I said, I can't. I'm never gonna win this battle. It's very nice to have you here. Jean, besides being an amazing author, she is also a great tennis player, ping pong player. And thank you very much. She's going to be presenting about Java's 21 certification. Thank you.
Thank you. Great. Welcome. Thank you for coming. As you can see, we have pizza and apparently cookies. Surprise. Also, we're going to be going to Shake Shack after this. If you would like to get a shake or beer or burgers, you can hang out with us and enjoy the shakes. All right, disclaimer. I do not work for Oracle, so we don't have to have the safe harbor disclaimer on the screen that we're all accustomed to. Instead, I have a disclaimer of my very own. I'm not authorized to tell you any non-public information or whether I know any. Take that as you may. Also, some of the material in this presentation may appear in our oncoming certification book. It's copyright by me. It belongs to me and not the internet, and I didn't steal it from anybody. All right, now we get to the actual reason that you came for this presentation, Java 21. Yes? Do you not want me to be muted? Uh-huh. Says I'm muted. Can I proceed now? Yeah. Okay, great. We've got all of our AV problems. But remember last time when we didn't start on time because we had AV problems? Today we're having them during the presentation. It's so much better that way. All right, so if you want to take a Java certification and be one of the first people in the world to take it, you pretty much have two strategies. One of them is you can decide that that's foolish and wait for the actual study guides to come out. The other one is you can read presentations like this and practice with your own questions and try to take the exam that way. Now, that's the purpose of this presentation. If you're trying to go the latter route, you have something to work with. The secondary purpose of this presentation, which is probably all of you, is people who have no intention of taking the certification but want to learn about the features. Because the study guide type of way of studying helps you realize the edge cases and the things that you may not think of. As a result, this presentation is fairly interactive because I want to make sure that people understand these features as we go. Starting out, what are we going to cover today? These are the topics that have any chance of being on the exam. Virtual threads are pretty much guaranteed to be on the exam, big feature. Same for pattern matching for switch and record patterns. Sequence collections may or may not be on the exam, probably not. And then other topics I want to mention are highly unlikely to be on the exam, but may affect you in your actual life as programmers, so I want to include them. And then any general Q&A. If you have questions about a specific feature, please ask while I'm still on the feature and before I've moved on with my life. This presentation will be online at speakerdeck.com/boyarski when I get home. If I put it on now, you'll all go and look up the answers, and that won't make this very fun. All right. Our first topic, unless there are any announcements about AV problems that people would like to deal with before that, all right, we're good, is virtual threads. Java's got a lot of leaps of concurrency. Over time, we started with the original threads. Raise your hand if you remember the original threads. Decent amount of work there. Then we got executors and the APIs, atomic integer, that sort of thing. and now we have virtual threads. Plus, of course, all the APIs that I'm not bothering to mention. So why do we need threads in the first place? Well, we could have our program that needs to make a bunch of REST API calls and do some annoying calculation, and we can do them one at a time, which results in the CPU being like, all right, you want me to do something? Wait, hold on, I have to go wait for the REST API, and the network's like, you're going to get back to me eventually. And in a situation like this, your CPU and network are both bored, and you're sitting around waiting for all these things to happen one after another. Not the ideal situation. And that was back in the day when we had one CPU. Now all your CPUs are bored, which is hardly better. We introduced regular threads, where you delegated all of this work to your threads, and each one was responsible for some number of these calculations and REST API calls. And this made it somewhat better because you were able to say, okay, we're going to wait on that slow network, but we're going to do it all at the same time. I use this a lot at work. I do a lot of stuff with COTS products and REST APIs, and some COTS products give you extremely granular REST APIs, which is super annoying. So you wind up writing a parallel stream and saying, you know what, run them all and tell me when you're done. Makes it a lot faster. But there is a problem here. Your CPU and network are still bored because the number of CPUs on your machine has greatly outstripped the ability to deal with them. And your threads, also known as platform threads, are directly tied to those CPUs. So you can only have so many of them. The network didn't get any faster. So all of your threads are sitting there like, yeah, I'm waiting for the REST API to come back. I'll get back to you one day. Sounds good to you. With virtual threads, you still have the platform threads, but they're abstracted from you, and you get many, many, many virtual threads running on the same platform thread. So that same delegation we did to the original threads is now happening kind of like N squared, where the threads themselves have multiple threads. This makes things a lot faster, and now your CPU and network are content that they have a sufficient amount of things to do, and your work is being done roughly as fast as you could get it done. I'm glad we've pleased the CPU and the network today because those are the most important things on our computer when we're trying to get stuff done. It's most helpful when you have thousands of threads. You need to have a large number of threads for this to be of benefit, or you don't have enough wait time. You also need something that's not CPU bound. You need to have some level of I/O in this, whether it's file system or network or whatever, because if you're already using up all your CPU, splitting it up into smaller sections just makes multiple things be using up all of your CPU and doesn't actually make things faster. That's why I gave the example of the REST APIs. That's something where you're waiting forever for things to happen and your machine has nothing to do. So let's compare platform and virtual threads. First thing to note is that platform threads, aka what we used to just call threads, are your traditional threads. They're fairly heavyweight. They're tied to the OS. They're pooled because they're super expensive and you don't want to have to keep creating them. And they're an instance of Java lang.thread. Virtual threads, by contrast, are super lightweight. While they run on the OS thread, they don't use it up, which is why you can have many virtual threads running at the same time. And they're often short-lived because they're practically free to create. There's no reason to pool them, which would give overhead of yourselves. You might have noticed I wrote something down. This is the world premiere of this talk. Yay. That means as I talk, I notice things or I see something someone's confused about and I make notes to make things better for myself. Does anyone have any questions on virtual threads thus far? Okay.
If you do have a question, wait for me to run over to you with the microphone.
Cool. In Java, you're able to use executors dot, if the dot's still there, in order to get your thread pool in different ways. You get one thread, which isn't terribly useful. You can get a fixed number, you can get a cached thread pool, and now you can get a new virtual thread per task executor. Pool. It doesn't have the word pool in it. Which says, okay, I want to run all these things as virtual threads. Please go forth and do it for me. You also might notice that executor service isn't a try with resources. That was added in Java 19. Yay. Before that, you had to call shutdown manually. Now that there's close, it calls shutdown by default, and then it does a tiny bit of extra work, which I haven't been able to have anyone prove to me is consequential. I asked on Twitter. Usually people are good about telling you you're wrong on Twitter. So either this is so new nobody knows about it, or it's a really edge case thing. But if you do a lot of concurrency, you should check. If you do a medium or normal amount of concurrency, it's probably good enough to meet your needs. And it does call shutdown, not shutdown now. which is what you want, right? You've asked the virtual threads or your threads to go do something. You probably wanted them to finish, which means you want shutdown of don't accept new stuff, but please do run the existing things, let them go to completion, finish. Shutdown now is like abort, we're all leaving the room, not running anything you're running right now. And that's very rarely what you want. You can also create your threads yourself. You can call thread.platform or thread.virtual to get a low-level thread object. You need that for any reason. You can also construct your new thread like you've been able to since the dawn of time. That's a platform thread because Oracle and Java value backward compatibility. And since new thread has always been a platform thread, it must always continue to be a platform thread. So you might have been thinking, that's it, right? I've seen presentations on this. There are way more to threads than what I just talked about. The reason for that is scope values are not in Java 21. They're a preview feature in Java 21. Preview features are not on the exam, and they're not things that you should rely on in your actual code. They're things you might want to play with. Scope values, huge topic. There's going to be a lot to say on this, and I look forward to presenting on it on the what is on the Java 25 exam. But for today, it's not something that you need to be aware of, and that is great because this is now an easy topic. I did not know that when I started writing this presentation and was dreading writing about scope values. Got a little bit of a reprieve on that, but they are coming, and they're going to be useful. They're just a little hard to understand. As an aside, they're a little like streams, where the first time you hear about it, it's like, that sounds nuts. Second time you hear about it, still sounds nuts. Then eventually, ooh, those are useful. I get it now. I'm just starting to get it now level of scope values. I need to hear and read about it a few more times for it to click. I know I'm going to love them eventually, but I'm still in them a little wary about this. It sounds a little screwy face. We're now going to do a couple of questions as a group to see if we've absorbed this material or if I can trick you. Or it could be either one, we'll see. So the first question is, how do we create a virtual thread? And before anyone answers, don't shout out the answer. First of all, we have a mic, we don't want to deal with that. Second of all, I want everyone to participate. So we're going to do this by raising our hands. I'm going to say something like, raise your hand if you think it's A. If you think it's A, you raise your hand. You don't say, I think it's A. All right, let's try this. Who thinks it's A? Good, it's not A. All right, now let's actually look at them and see what we think is going on. Who thinks it's B? C? Got one tentative hand. C is one of the answers. Very good. Who thinks it's D? No. New thread does exist, but that's a platform thread. They did not make a constructor for virtual thread. Who thinks it's E? A bunch of hands. Yay, it's E. Who thinks it's F? No, it's E. It's C and E. All right, great. That was a warm up. That was not meant to be tricky. Made sure people were paying attention. That is a fair point. And on the topic of the world premiere of the talk, I'm going to write it down.
You want to just mention that again?
I was just saying that the way the question is worded, C technically is incorrect. You could use that code indirectly to get a virtual thread, but not that itself does not create a virtual thread.
Yeah, that is true. And it is important because people have to be very literal in the space. So that is an excellent point. And I'm going to change the wording of it when I update this. Okay. So you're going to have the same issue with number 2, pretend it's better worded. How do you create something that has to do with platform threads? I'll try to think of something more elegant. I'm going to pause for about 10 seconds and let us read this, and then we'll see what people think. All right, who thinks it's A? Yeah, we got some A's. A is one of the answer. Great. Who thinks it's B? Nope. Great. Who thinks it's C? Nope. That one's tricky because it's like the virtual thread one, but it doesn't exist. Who thinks it's D? Yeah, that's the way we've been doing it since the beginning. Who thinks it's E? right? They did not add a constructor for platform threads. And who thinks it's F? Yep, great. You're all paying attention. I promise they're not all this easy. All right, next up is what is true of do stuff at line V1? We've got a try block, var service, equal executors, new virtual thread per task executor, which we just learned is the mouthful this thing is actually called. We submit a service, and then we have the end of that block, and then we have line V1. So who thinks that do stuff might still be running? Okay, we got one for that. Who thinks it was killed? Nobody. Who thinks it completed? Nobody. And who thinks it's D? None of the above. I'm trying to trick you. Got 1, 2 on that. Rodrigo always thinks I'm trying to trick him. I'm not trying to trick you. It is C. Remember in Java 19, they added with resources auto-closable. It calls shutdown, which relies on the elegant completion of the thread. So the try with resources sits around until do stuff finishes, at which point line V1 it has in fact completed. Yeah. Shutdown waits until it is complete. Shutdown now says shutdown right now, we're killing the world. Does that make sense?
I didn't realize that it waited. I just thought it started to shut down, and I didn't realize.
It can't because the threads are still in use. That's a really good distinction. If it started the process of shutdown, that is what shutdown now does, right? So say that my thread pool is using 5 platform threads and I do shutdown now, it's no longer using any platform threads. That's an impediment to doing work. And it's the same thing with virtual threads. Once the pool is closed, the virtual threads are all gone. So shutdown is waiting for them to complete and then ending. Good? All right. Yeah, so that's why we're here, learn stuff. And because I'm all animated and you learn to hear, you're probably going to know it forever, which is even more useful. All right, that completes this section of the presentation. The other thing you might see me writing down is some numbers. I'm writing down what time I transition between each section because that helps me know whether I'm on track.
So methodical, Gene. I'm always amazed.
World premiere. You always are my guinea pigs. I mean, people who are learning stuff. I can do 2 things at the same time. All right, next topic is pattern matching for switch. This is an evolution of a feature. We started with switch expressions, which are the things with the arrow. We'll see those shortly. Then they added pattern matching for instance of, where you didn't have to cast as much. And they added pattern matching for switch, which we're talking about here. Record patterns, which we're talking about next. And in the future, they will be adding unnamed variables and patterns, which is the underscore thing where you don't have to give a name to your unused pattern variable to make it clear that it's not impacting use. And what I showed with the preview versus final features here is each of these features was in preview for at least a while. And that was so that they could really test out the feature, make sure it made sense, make sure the syntax was going to be final before it went live. And at least one of these features did change the syntax during preview. Which was good. That's part of why pattern matching for switch had 4 previews. You had to get it just right. Because we all know that once something's in the language, it is going to be with us forever. So they want to make sure that when it goes live, it is what is actually wanted. Each of these previews is 6 months. So it took 2 years for pattern matching with switch to settle. And now we have today what we're actually going to talk about. All right. So we've got some code here. This is not a trick. This is your traditional switch statement that's been around since you learned Java. Can somebody tell me how many lines this prints? I'll repeat it so Barry doesn't need to run around with the mic. Anyone? 3. Yes, 3. Because the breaks are missing, right? So it matches on Vegas and then it prints table games, lotto, and maybe. The Vegas theme is because we are in Java 21 and Java is now old enough to gamble. I need some more images for that. I ran out of time. But yeah, 3. Then with switch expressions, you can see there's an arrow there instead of a colon. The situation is much better. It only outputs 1 line, the one we want, which is KC. Also, I seem to have not changed this example to mention Vegas. I was hoping to do that. Oh, okay. Hey. I have two versions of this talk because my piece of paper doesn't say homework. All right, anyway, that's not the point. The point is that we're using arrow labels. The arrow label is what makes it a switch expression and prevents us from having to use a break. This makes the code easier to read, easier to understand, and prevents the bug we just saw with the 3 lines of code. It also, you can do this with a regular switch now too. You can put multiple values in the same one, which also makes it easier to read because you're specifying the intent a little more clearly. This is the slide I was expecting to see. So I have a duplicate slide is what's going on. This is the exact same example, except for Vegas themes. Okay, now that was all here before Java. What's new is adding pattern matching to it. These expressions that we have as their cases in the switch are our patterns. Kind of like an if statement, but a lot more succinct. So our first pattern is what happens if object is null. If object is null, we're going to return an empty string and be done with it. Then we have some patterns that are types. So, well, is object an integer? If it is, we're going to be able to refer to it as I. You saw this with instance of in earlier versions of Java where it would assign the value. And now I can refer to I. I'm going to say when I is greater than or equal to 21, I return Ken Gamble. The next line is the case where it's an integer. And obviously it's an integer that's under 21 because we already dealt with the case where it's over 21. So too young to gamble, go away. Next I check strings. So is it a string? If it is a string, is it poker? Is it craps? Is it not? In which case it's some other game. And then finally, I have a default. I have to have a default because my switch expression returns a value and I can't return a value or assign a value if there's nothing there. You can't just return undefined. So I either have to have a default that returns a value or throws an exception to make Java content that I have in fact handled the cases. The exception is when you have handled all the cases. If this was an enum and I listed all the enum values, the compiler is smart enough to know that this was exhaustive. You don't need a default. But in my case, there's a long list of things I could be. And since I didn't say anything about objects, there's no catch-all. So I have to specify what I would like to happen. When is a piece of new syntax, the one that changed between preview and release. It's known as a guard clause, which is I have my pattern that matched. When do I want it to take effect? Well, I want it to take effect if I is greater than 21. Then I have the pattern variable. That's my I or my S. It only exists within the pattern. It's scoped to that piece of code, which could be the when and definitely the thing after the arrow. If I try to use it afterwards, it doesn't compile. Just like if I defined a variable inside of the body of an if statement and tried to use it later, I was going to be like, I don't know what you're talking about. There's no I. Right? And it's the same thing here. I can't refer to I in my default case and expect it to have meaning because it didn't match. It never got defined. As I noted before, you can have null. What is really interesting here is that the order does matter because it's looking for things in the order that they're in. So in this case, it doesn't compile. The null is fine, but if the null is fine. But the second line says if it's an integer, say too young to gamble, then it says right after that, if it's an integer and greater than 21, well, you're never going to get there because on the previous line, it returned too young to gamble and there's no integers left. So there can't possibly be an integer that is over 21. You've seen this before as well. We do this with catch blocks and exceptions, right? I can't catch an exception and then below it catch a runtime exception. That doesn't work. It's the same principle here, right? You have to have something that is going to make sense in logical flow so that Java can match it. And the compiler will tell you you did this wrong. So if I write this code and it doesn't compile, it's like, oh, okay, I have to reorder these two statements or get rid of one or do something because this code is no good. I mentioned enums before. I don't have to have a default case with the enum because the enum is able to say there are only 4 suits in the deck. So it's got to be one of these 4 values and I can return it. And it'll fail compilation. Not new. It's the same thing for your case switch statement. If you do that, it will say that you have, as you can see here with the switch statement, I have all 4 cases represented. really cool that you can use the Unicode values, by the way, to represent these symbols. Oh, Oh yeah, I know the answer to that.
The question was, what is
Yes.
no?
Yeah, I took a moment because I forgot the answer, but I remember the answer now. It took me a minute. I tried this. The answer is it resorts to the default behavior of a switch statement, which is to throw a null pointer, which is what happens with a traditional switch statement as well, and invariably where you got this from. So you can handle null, but you don't have to. And I'm going to write that down to make it clearer or possibly make a question about it because it's a good subtle point. So I don't have to write null, but if I wanted something nice to happen that's not a null pointer, I do have to have a switch null, a case null. Good question. Okay. Next up, we have a switch statement here that is fairly routine. It is saying if integer is less than 40, we're going to set check to true. Otherwise, we're going to check it to false. This is fine. Next up, we have our pattern variable scope. This is what I was talking about before, where I can only refer to I in a place that is going to make sense. Does anyone see what's wrong with this? Yeah.
Oh,
Oh,
there you go.
Barry's holding the mic.
You're not using arrows, you're using colons.
Yes, I am. And that means I can fall through. I'm not because of the break, but because in theory I could fall through. It's unhappy about this because I is still in scope. Right? So since I have the ability to fall through on that second line where I is less than 40, there's two entry points to that. So it's ambiguous as to whether the original I is still in scope or not. And Java solves that by saying you can't do that.
So they added pattern matching, not just the new switch statement, but to the original one also.
Yeah. They did that as well with the, you can select multiple case values, except that one I use in the classic switch. This one I have trouble believing I have any use for in the classic switch. Because the classic switch is messy. You have to remember to add breaks, and that makes the code longer to use.
Sometimes you do want to fall through, though. It may be rare, but sometimes you actually do want to do it.
And that's the case where you would use it. But 90% of the time, I find that I don't. So that's the distinction here. If I was using arrows, this would be just fine. But because I'm not using arrows and I'm using colons, I've got my classic switch, and now this is ambiguous. You're in the middle of the room. I think that works. Okay, so there are still some things you can't do, switches are not magic. X still can't be a Boolean, float, double, or long. And you can't use underscores yet. In Java 22, that is supposed to go out of preview, and then you'll be able to use the underscores. The deal with the underscores is if I don't want to use something, and use an example here. My case integer I too young to graduate. It's like, well, you know, who cares what I is? I don't reference it. I can use an underscore to specify that. That'll be really nice when it comes, but it's not something that's worth holding up the feature. So I'm glad that they delivered without it, and it's coming later. Do we have any questions about this before I ask questions?
Why didn't they allow long? There's just too many of them? Or, I mean, they allow integers, but not long?
I don't know. It hasn't been allowed in a switch statement since the dawn of time. So I'm highlighting that that hasn't changed, but I don't know what the original reason is. I'm guessing in practicality, but you could use a default. So I don't see how int is any better than long in that space. Does anyone know? The question is why long isn't allowed in a switch. We have speculation that maybe it's a bytecode issue. Could be. It's certainly possible that switch isn't optimized for it. It's as good an answer as any. Yeah.
I mean, in a classic switch, I understand why you wouldn't want to float, but now that we have patterns and you can, you know, have boundaries on the floats, maybe it would make sense. But
Yeah, long is just
Can you say that again?
What I'm saying, Lon, is that, you know,
Yeah.
from a programmer perspective who is not looking at the bytecode and everything, it's just like a longer integer. So it doesn't have any precision issues
Right.
or anything. So it can be compared directly.
Yes. So the literal answer to the question is because it used to be that way, but that doesn't explain why it hasn't changed. Any other questions before we go on to my questions? All right, question time. They're more interesting now. There aren't that many code questions you can ask about virtual threads. Okay, so we have our first switch pattern matching exam question. How many lines do you need to remove to make this code compile? I'll give you 30 seconds to read and think about this because you do have to read all the lines before I ask you. Ten seconds. All right, who thinks it's A? Thinks it compiles as is? Nobody, great. That means you're listening. Who thinks it's B? Still nobody. Who thinks it's C? All right, got a bunch of hands on C, and who thinks it's D? One hand. Great. I think it's 2, so we're going to see why we differ. So you definitely have to get rid of the first line, the K string S, because it's before the 2 other lines about our gambling games. And I need to get rid of that one instead of the other 2 lines because I'm trying to remove the minimum number of lines, which is it's not saying the question. And then I also need to remove either the last line or the second to last line. Case object O handles all cases as is default, so I can't use them together because one of them will be unreachable. Yeah, spoiler, it's the second one. But if I had reversed the order of that, I'd have the same problem in reverse. So to the people who thought it was 3 lines or 4 lines, are there any lines that I didn't mention that you would think that you need to get rid of? Sorry? Are you still holding the mic?
Can you write a number just starting with a decimal point in Java?
Yes.
I didn't think you could do that.
Yes, you absolutely can.
Was it always been that way?
Price? Okay, so that's how you got 4. You were counting those 2 lines. Okay. I did run this example, by the way. But in general, I always leave out the decimal point, so I'm very familiar that's okay. And the robotics students I mentor also leave out the decimal point, which is memorable to me because I have to remind them that you have to cast things to double when you want them to be doubles, because I'll often see 0.5 with no double, and then that goes horribly wrong when you start dividing. So it is 2. You have to get rid of string S and either object O or default. Okay. Now we've got our next question. What are the results of calling odds of slots? Pretend these are actual quotes and not smart quotes, and odds of null. And again, I'll give you 30 seconds to think.
Give you some questions or
They are, yeah,
Yeah.
there's probably 2 answers to the question.
just the way the slide is worded, you expect like both of them to be the same answer. So.
I'm going to answer this one because I think it's wrong. I think my answer key is wrong. So the intent of the answer was for it to be A and B. A, because slots is not one of the 2 table games, so trigger the illegal argument exception, and B, because it's passing in a null. But I don't think it actually throws the null pointer because maybe it does. I think I ran this, so I think it does. I think the logic for the null pointer is that this is exhaustive because we're passing in a string. So the last case string of S covers everything, but it's a null, so it's not fully a string and gives you a null pointer, but I'm not 100% sure of this, so it's possible that it's D. I have to run this one again and find out. So I think A and B, but I'm not sure. So if you answered anything, you absolutely get credit for this. All right, and then we have one more question. This one actually works. It's the same deal. We're making two calls, odds of slots and odds of null, and we want to see what happens. Who thinks it's A?
First one.
For either of them, yeah. Yeah, A is one of the answers. Great people, good. Who thinks B? No, two people. Who thinks C? Bunch of people, it is C. It's A and C. When we pass slots, it uses the string S that didn't match either of the whens, and when we pass null, it gives us 0 because we've explicitly told it what to do during null this time. Progress. Now we have our last big section, records patterns, and then I have more odds and ends, and then you can get here. Record patterns. Oh, question.
You just, slide.
Just curious, like normally if there was in the case of an object, there is a case of the object value being something,
Mhm.
like the first 3 case statements, and the 4th is a null.
Yes.
So why, like in this case, it seems exhaustive, but it's not part of a compilation error or a
In this
language
case, it is
feature.
exhaustive because string is a string and not an object.
Right, but the null, right? So every object can be null as such.
Yes.
So at a language level, any insight as to why they would have differentiated this?
Oh, right. Because if you don't specify case null, you get a null pointer per the existing behavior of switch. So you need to actually type case null yourself if you wish to have different behavior.
So to keep the current behavior.
Yeah, that makes sense, right? Because all the code has to be backward compatible. You don't want it changing its behavior in weird ways. So it has to throw a null pointer. The problem is with pattern matching, you often want it to not throw a null pointer. So they had to add a way of making that happen so that you could write new code in a better way. But if you leave out the case null here, this code will absolutely compile. It will just throw a null pointer instead of 0. Any other questions on switch pattern matching? Okay, record patterns, last big topic. We have two enums here, the suits and the ranks. You don't have to count them. All 13 card ranks are here. And then we have a record card that has a suit and a rank. This is your normal standard deck of cards. There's nothing weird or sneaky in it. And I can do if card instance of card C. I was able to do that before Java 21 as well, thanks to instance of pattern matching. I did C suit and C rank. What I can do now in Java 21, which is new, is I can expand it all in one line. So I can say if card instance of card suit rank, and I've got those variables available to me as if they've always existed inside of the if statement. I don't have to keep writing the C dot. So I now have a deconstructed variable where I have access to each of the pieces of it directly. A little easier to read and becomes more useful, as we'll see shortly. I can also do this with nested record patterns. So this is Vegas. You have to have more than one deck or people would be able to count cards. So I now have a multi-deck, which has a deck number and a card. And I can deconstruct my multi-deck into my multi-deck with my deck number, my card, and then deconstruct the card into suit and rank and use all 3 of those things as if they're objects, instance variables that have been available to me. But where it gets useful is back to our friend switch pattern matching. Because now I can match on my complex deconstructed objects. So I've got my case, I've got card, and I've deconstructed it into suit and rank. And then I can use the when and do operations on those things. In this case, I'm checking if the suit is heart. And if I got any other card, I return other. That makes it exhaustive because I got passed in a card and my choices are a heart or any card. And I can only do this because of deconstruction. That makes all of the stuff available to me inside of the case of the switch expression that I've deconstructed my value in. We'll leave this up a second because this is something to process. Now I have a switch expression where I'm just checking a string if the case is hard. That's okay because I'm printing it out. I'm not trying, oh, it's yeah, I'm not assigning it anywhere, so that's fine. Then underneath it, I've got my switch expression, which is basically the same thing. And you can see that they have to be exhaustive because I'm using when. And I need to make sure that I have something that's a regular card in order for this to make sense. Oh, I know what happened. So I know why my piece of paper is weird. You're going to learn something that has nothing to do with Java. My printer was broken, so I needed to email this to somebody who didn't use Keynote. So I converted it into PowerPoint and then I converted it into PDF, and it didn't put the slides in the same order they are in my presentation. Isn't that fun? And I'm like, this is not what I have on the screen. It's fine because I'm not using it. I'm just taking notes on it, but I understand now why that was a jumbled mess. All right, so what can't you do? You still can't use underscores because unnamed patterns are coming in Java 22. And you can't expand classes that aren't records. So I can't just pick a random class and deconstruct it into its variables. Maybe that will happen one day, but it hasn't happened yet, and it's not in preview mode yet. Any questions on record patterns before I ask some questions? All right, question time. Which of these do we think compile? There could be more than one. Okay, do we think A compiles? Yeah, we got a lot of hands. A does compile. This is how you would deconstruct card. Do we think B compiles? Everybody's afraid to respond. Yeah, we got a bunch of yeses. B does in fact compile. You're allowed to use var. You can use it in a loop. You can use it in a lambda. You can use it in a record pattern. Do we think C compiles? Yeah, nothing wrong with C. Pointless, but it compiles. Not that A and B do very much. It's an empty if statement, but you know, it can. And what about D? Do we think D compiles? No, D does not compile. Yes.
Would A compile if you reverse the order of suit and rank?
I'm 90% sure that it doesn't, but I'm going to run that when I get home and check. We got another no, which makes it likely that it is no. The reason I don't think so is because you could get into positions of ambiguity that way. Like, what if your record had two things of the same type? I feel like that would create chaos. And also with records, there is a defined order to things. They're the order that you put the fields in the record. So I'm reasonably sure that it would have to be in this order, and Rodrigo agrees with me.
If you can use var, then it makes sense that you can't, you have to specify.
Oh, that's right. With B, you'd have a major problem if you did that. So now I'm 100% sure. Thank you, Barry. Yeah, it would be meaningless if you were allowed to. I'm making that a mock question, though. That's a great question. Thank you. Any other comments or questions on this slide? Okay. You can't change the deconstructed values in the record because records are immutable, but you can they're not, but you can say suit equals suit dot whatever. You know, please don't. That's like reassigning an exception in a catch block. It's legal, but it's a terrible idea. But I can't say on like C dot set suit to whatever because records are immutable. Great question. I think I repeated it in my answer. Okay. Now we have our second question here. So we've got a card. It's a heart, two of hearts. And then we've got a case statement. And we want to see what we think happens here. I'll give you 30 seconds to process. No tripping on the floor. Right. Can't do that. All right. Who thinks it's A? Nobody. Who thinks it's B? Still nobody. Who thinks it's C? Still nobody? Who thinks it's D? Yay! It is D, and the reason it's D is because there's no case card. These are not mutually exclusive. Okay. This is the same example to save you some reading, except that I've added case card. Who thinks it's A? Nobody? Who thinks it's B? One person, you are right. Congratulations. It is B. This is long, but it's not really intended to be tricky. We've got a 2 of hearts. The first case says it's an ace of hearts. Nope. The second one says, is it a heart? Yep, that's us. Okay. My next topic is a topic in the sense that I presented it as if it's a topic on the exam, but it's not a topic that I actually believe will be on the exam. But I find it still to be a useful way of teaching, so I'm covering it that way. Okay, so we've got a normal example here. Does anyone have any thoughts on what this outputs? I'm giving Barry a lot of exercise. Sorry, Barry. Yes, we got it. The answer was one of those, and that is the answer because it's not defined. Right? And that's the problem with regular collections, that who knows? It happens to be Mickey on my machine, but that's not defined. It could change if I move to a different machine. It could change if I update my JVM. It could change because anything, right? Not defined. So in Java 17, this is what the collection class looked like on a super high level. We have lists and queues and sets and maps, and that was all very good. In Java 21, some of these became sequence collections, and they added 2 more, linked hash set and linked hash map, which do define the answer to that question. And they inserted them in the hierarchy. You can see some of the green insertions here are sequenced interfaces or pretty high up because this was retrofitted into classes that already existed. Right? We had a lot of list type structures that did have a defined encounter order, so they added the interface above that. Same for set and map. And they added some methods. And you might be thinking some of these new methods don't look that new to me. And that's true because a lot of these methods existed on some of the lower level collections classes. What they did is they drew them up, put them in the interface, and added them to the ones that didn't have them already. So that you can use these methods that you're accustomed to using in a lot of places that you weren't able to use them before. So now, if I use a linked hash set, this is defined, and I'm going to get Donald. You might note that linked hash set is not new, and that's true. It didn't used to be in the sequence collection interface because it didn't exist, and a lot of people didn't know it existed, so it suffered from a PR problem, but it did exist before, and now it's part of the legit sequence collection framework. So I'm not going to quiz you on this, but this is what I just talked about of which of these are things that you can do, and the answer is A. Sequence 4 and sequence 5 are things that you can actually do here in Java. Okay, now we have a couple of things that are good to know and have nothing to do with the exam. Absolutely.
The A is 1.
Hey, look at that. Huh. It is. I didn't proofread that slide because I was going to remove it. So I will choose whether I'm going to fix it or remove it. Originally, I thought sequence collection had a higher shot at being on the exam than it actually was. And then as I started writing it, I decided that time had passed and I no longer felt that way. So stuff that is highly unlikely to be on the exam, but you want to know as actual Java developers. First of all, UTF-8 is the default character set when reading a file. For some people, this is going to be really, really good and really, really helpful and save you code. And for some people, it's going to make your code break. This is why it's good to be explicit about what character set you're using. And you have the opportunity to do that now before you upgrade to Java 21. Start changing it to be explicit or see that at least that it works with UTF-8 so you don't have any unpleasant surprises. String builder and string buffer now have a repeat method. You don't have to route them through string anymore. String has a new index of method that and a string split with delimiters method. Unlikely to need them, but might be handy in some circumstances. Code snippets are formalized in the Java doc. I'm super excited about this one. I don't think it'll be on the exam because JavaDoc has never been on the exam, but I am excited to have a clear way of expressing code snippets in Java. And finalization is deprecated for removal. Woohoo! That said, there are like 20 things in the history of Java that have been deprecated for removal and actually removed. I think that number will increase over time because people have had more time to get used to the idea and settle. But I'm really excited for finalization to not be in Java because people shouldn't be using it, and it would be nice to not be an option. When I tweeted about the number of things that have been removed or the lack thereof, because it was super hard to find an example, Stuart Marks, aka Dr. Deprecator, said that he needs to work on deprecating more things. So he has two jobs, deprecating things and removing things. Make sure that Brian is not in room when making jokes about deprecation. Got it. But that's what I heard. Are there any questions about anything I've said before we do the book giveaway?
They bring up a new index of method. It had one already.
Right. It has a new one. It has more parameters. I think you can specify you want the index of the thing after a certain match or a certain index or something. I don't remember it by heart. I don't like index of to begin with, which made this hard for me to memorize. I find that my colleagues use index of most of the time because they're afraid of regular expressions and write something that's ridiculously complicated and involves index of and substring when they could just say remove the thing with a caret that begins with an S or whatever. So every time I see index of, my first thought is, does this really have to be index of? Including right now when you ask the question. Any other questions? Sorry.
No problem. I just want to take your opinion on this. We went over it very fast, but one of the concept that was introduced that I still have problem with, even when I start seeing it in the code and the code reviews, are the usage of var. So till this moment, I find it very challenging to approve any code that like started using it. And since we have more developers now that are coming from like Python space or like JavaScript space, they want to aggressively use it. And I still have a problem with it. So what's your opinion in it?
What is it referred to?
Sorry?
What is it referred to? You said it a lot of times. I missed what it was.
Oh, a lot of times I see it in the usage of var, like across.
Oh, var.
Yes.
Okay, that was the word that I missed from that.
What's the problem that you have with it?
So the point was var can make code harder to read, right? And I use var in a couple of the examples. I like var selectively. I like var when it doesn't make things any clearer, right? An example of that is path equal path get, right? If I use var, you're not forgetting it's a path. Another case where I like it is if I'm in a traditional for each loop, because it'll be like, all right, build builds. I'm aware of this, thank you. So it's just adding clutter, but I like it in stuff like that. I don't like it when it's everywhere because now I have to mouse over to see what it is. I don't like it when it's confusing. So, it depends. I think like any feature, var is good, but can be overused. That said, I also do a bunch of stuff in Groovy. Groovy has def instead of var. I'm always mixing those up and then my code doesn't pile, but that's besides the point. I use it almost all the time there. And the reason it's different is 90% of stuff I do in Groovy is in the scripting console where I'm never going to look at it again. So it's just a time saver. When I'm doing things in the actual pipeline, I actually think about whether I want to specify the value. But what's interesting about it is I do use def way more in Groovy pipelines, even when I'm keeping the code, than I do in Java. And I think it's because I learned it that way, which is probably why your Python and JavaScript people are doing it. They're more comfortable with a higher usage of not showing what it is because they've always done it that way. I have gotten more comfortable over time though, so your mileage may vary. Any other questions? Okay, I'm gonna do a book giveaway, and I believe that Barry wants to end the stream before I do that.
I will do that.